Okay. Again, we have our truncated, sort of truncated by some shape, rectangular prism. And let's go ahead. Okay. And we have a normal vector, or proposed normal vector, that's, it'd be an approximate normal vector for this thing, but we do the cross product of this vector with this vector, okay, and we've done that, so it's clear how that's done. We get this normal vector, and this point is, let's say, 0, 9/3. Now, we want to get some way of representing all points in this line in a single formula, or maybe in 3 formulas, depending on how we want to parameterize it. So what we do is we say, okay, vector from the origin up to this point, and just for example, if we do -3 times n, that would be a vector back in this direction. It's this long, right? So -3 times n would be 1, 2, 3 in this direction. Comes down to this point. Okay, so this vector is the vector. Here, just 0i plus 9j plus 30k, because that's a vector that takes you from the origin up to this point. And then we have a vector -3n. Well, that vector is just, multiply it out. -3 times 0.9 is -2.7. And then we're going to get plus 3.3j plus 9.6k. Well, what are the coordinates of the point that we end up at then? I'm going to give you a few seconds to see if you can write out the coordinates of that point. And don't say anything, because I've got the recorder on it. I don't want to. Unfortunately, I can't pause this thing and resume. Okay, again, coordinates at this point would be.
Yeah, but this is what I'm talking about.
Oh, you're saying I made a mistake? Yeah, it's negative, isn't it? Yeah, it ought to be -9k. And if I look at it with common sense, as I was talking about when we consider what we're doing, it's obvious that this is not in the positive k direction. So if I'd have looked at what I did, I'd have seen, oh yeah, duh. Okay, because it's -3 times 3.2 is -9.6. I was more worried about staying and not going over the edge of the board than I was about getting the sign right. Okay? No excuse. So what are the coordinates of this point? Okay, well, I'm not going to give you a whole lot of time to think about it, but I did want you to think about it. So, the coordinates of this point and another good color here. I don't want to get too carried away with color. Let's instead ask, what are the components of this vector? Well, this vector is clearly this one plus this one, right? So if we add the two vectors, this vector here is 0.9i minus 1.1, no it isn't, I'm looking at the wrong vector. Another multi-billion-dollar spacecraft on the surface of Mars and pieces. Okay. It's this integer here. Don't really have to write the 0I, but I'm gonna do it. And I did it again. But I was thinking that time, so I caught it a little quicker. Okay. Plus negative 2.7i plus 3.3j minus 9.6k. And we usually add that up. I can do the addition. Negative 2.7i plus 12.3j plus 20.4k. Okay, does that make sense, at least as far as the signs are concerned? And it doesn't. But maybe my picture is a little distorted. Looks like that's going in the negative I direction. Clearly going in the negative I direction. It doesn't match my picture. My picture didn't get the cross product or something. If this is cross product, then 0.9i would have the thing out in this direction, right? So my picture isn't very good. So I would either want to draw a better picture to reconcile it, or accept that, well, because I had a positive line that goes in this direction, really then the line ought to be back this way, so the I component ought to be negative. The J component, appears to be positive, which is consistent, okay? I got it this way. And the K component is positive. Now the numbers, the K component isn't big enough, but that's because my picture doesn't really represent this vector very well. Okay? It's going to be in this direction. I probably should have used negative 0.9. Okay, so picture isn't good, but the principle is simple enough that if, what are the coordinates of the point that you get if you start at the origin and follow this vector? Well, the coordinates should be obvious, are okay? Well, that's one point on the line. How could we get another point on the line? Well, just pick another multiple of n and do the same thing. Okay? Well, it's going to take me a while to get all the points if I just go around picking numbers, since there's an infinite number of them, an uncountably infinite number. So that's not practical. So what we want to do is we introduce just a symbol for our multiplier for n. Okay? What symbol would you want to use? Everybody's favorite Greek symbol, omicron, right? Everybody can write that one. Okay? Well, no, maybe not. You know, I don't remember how to write omicron. Haven't used it in years. And when I read it, I just think, oh yeah, there's that Greek symbol. That's what it looks like, and there it is again. So, you know. Okay. So let's stick with the English alphabet and lowercase numbers. Okay, what would be a good lowercase letters? What would be a good lowercase letter to use for our parameter? Our parameter is going to be whatever we multiply by n.
D, E, P, P.
Did you say T?
P, or T and P. I said P, but if T's the right answer, I said T.
I'm still not sure what you said, but okay, that's just my hearing. Sounded a lot like T. And that's exactly what I would use. So if it was T, you know, you can claim, have a mind that runs along the same path as mine, which is not necessarily an advantage. Okay, but that was a good answer. Okay, so I'm going to use T. That's what I was going to use no matter what you said. Okay, so I'm going to say, okay, let's see. Here's Tn, right? So I'm going to ask you to do the same thing that we did here, but with the vector Tn instead of the vector 3n. Of course, 3 rhymes with T, but yeah, okay? So let's see what you get. Draw the picture.